Hello students and welcome back. So we talked about binary to gray conversion. Now let us talk about the opposite, and that is gray to binary converters. So in this video we are going to talk about 4-bit gray to binary conversion and how can we implement it in Verilog using case statements. So let us get started. So gray to binary conversion using n bit, we are generating 2 raised to power n numbers. So if I have 4 bits, I will map 16 gray codes with the respective 16 binary codes. We are going to solve 4 k maps because in my output side I have 4 variables. We will get their Boolean expression and we will implement it. So this is the simple process that we are going to follow. So now when we talk about the converter, the truth table is here. These are total 16 entries. We have just shown them in 2 pieces. So on the left side, we have G3, G2, G1, G0, and on the right side, B3 to B0. So gray codes are being converted into respective binary codes. Now what we will do, we will solve 4 k maps. And when we do that, we get the following expressions. That means B3 is coming as G3, B2 is coming as the XOR of G3 and G2, B1 is XOR of G3, G2, G1, and B0 is XOR of G3, G2, G1, G0. So now you can see that the data flow implementation using Verilog is quite easy. It is just 4 lines of code. You have to just say assign B3 equal to G3, assign B2 equal to this, and assign B1 and B0. A very simple code. So now let us talk about the implementation. When we talk about data flow, I have already explained these are only 4 lines. But we can also do it using case statement, where using 4 bits we generate 16 case statements, and for each of them we explicitly mention that what is going to be the output. So let us check this out on Vivado now. So we are creating the file here. Module name is G2B using data flow, and here I give my input port as G and output port as B, and I click on these buses. It is a 4-bit, so we will just go up, and here we are going to observe, just expand these. Okay, expand it so you will see it clearly. Here you have MSB, LSB. 4 to 0 means 5 bits, so keep it 3. Here also 3. So 4-bit input and 4-bit output. That's all. And we say OK. And now we are going to write the code for the same. So here we have G2B, and we say assign now. Our statements were that B of 3 is equal to G of 3. How to access that index in a vector? Well, that is done using the square brackets. So what we say, assign B of 3 equal to G of 3. Okay, that's all. Now what is our next assignment? We say B of 2 is G of 3 XOR, this is the symbol for XOR, G of 2. And then we just follow the same thing. Assign B of 1 equal to G3 XOR G2 XOR G1. Okay, and similarly we are going to assign the last one, and that is B of 0 and that is XOR of all 4 bits. So that is all that we have here, and we are going to see that what is the schematic for this coding. So the schematic is ready now, and we can see that finally B3 is coming directly through the buffers of G3, and then 1 XOR and then 2 XORs and 3 XORs to get the B2, B1 and B0. Now let us code it using the case statement as well. So here we are going to declare the gray to binary using case statement. So first of all, we say input wire 320G, output register 320, and that is B. So these are explicitly mentioned as wires and registers. Here you can put it like this. Okay, there are wires and registers. What else do we need? Now we are going to write the procedural assignment. So we say always at the rate and the name of input variable, and that is G. So we say begin and end. So this is the begin and end of always block. In between we are going to write the case statement. So now what we are going to write 16 cases for gray to binary conversion, and what we have to do, we will just look at the truth table and mention those cases. So here we have these cases, and please take care that you mention 4-bit binary number. This is my first case. In this case B is allocated this value, then in the next case, and in all the cases what is allocated to B. Now let us check the schematic for the same. So we have the schematic here where 4 bits of gray are being converted to 4 bits of binary, and there is a block which is doing this computation. Now when we write this code, please make sure we are using procedural assignment, so we have to allocate registers, and do not forget to mention the input and output in the module declaration as well. Otherwise it is not going to connect your codes in the schematic. So this is about the case statement implementation for gray to binary. So students, now we have discussed about code converters. We are going to discuss one more type of combinational circuit, and that is comparator. Keep learning. Thank you.